Hello and welcome to LuckyMath. Whenever I was talking about the logarithm in my earlier videos, I said the following, namely that it is a function f that takes you from all real positive values on the x-axis to all real values on the y-axis. So it takes an argument x that is positive, and this gets mapped to the log to any base a of this argument x. Not only do we have a restriction on this argument x, which should always be positive when we deal with logarithms, but also we have a restriction on the base a. And this base a should not only be real, but also positive and never equal to 1. And in this video I'm going to point out why this restriction has to be fulfilled. Now, if you've seen my earlier videos on the exponential functions, which are the following, f of x is equal to a to the power x, then we had the same restriction on this base a. And if you've seen the video up there, then you should also know why. If you know that the logarithm to base a is simply the inverse function of a to the power x, then it should be clear that these bases a are the same in the logarithm and also in the exponential function. Therefore, the restrictions have to be the same as well. But for now, let's just assume we have no clue about exponential functions, and let's just try and look what happens if we set a equal to 0 or less than 0 or equal to 1. So let's just get started by setting a less or equal to 0, which it shouldn't be. So then we would have that f of x is equal to the log to this base a of x. And in the next step I'm going to use the change of base formula, and I have a separate video on it up there. And we can rewrite this as the log to some new base b of x divided by the log to this same new base b of the old base a. And the new base b obviously has to be real, positive, and not 1 as well. Can you see the problem? The problem lies here, because we take the logarithm of a negative argument, or an argument that is 0. But we said in the beginning that the logarithm can only take positive arguments, and therefore this is not defined, and therefore this whole expression not as well, and this wouldn't be defined either. So as soon as we take a being less or equal to 0, we have a problem. Let's do an example also. If a was equal to minus 2, then we would have the function f of x is equal to the log to base minus 2 of x. We said that the logarithm should be defined for all real values of x that are positive. So also, for example, for x being equal to 2, then this would be the same as the log to base minus 2 of 2. And you know that this has to equal some value y, and this y tells you minus 2 to which value, so to which exponent y will give you 2. So this is just the same as saying minus 2 to which power y will give you 2. And I don't know a solution for that. Maybe you do. If you go to complex variables, you're going to find one, but we're not that far yet. So yes, you really have a problem as soon as you take such values. Therefore, don't do that. So now the plus sign should be clear already. What's left is what happens if a is equal to 1. Then we have that f of x is equal to the log to this base 1 of x. And let's again use the change of base formula, which gives us that this is equal to the log to this new base b of x divided by the log to the new base b of the old base 1. But b to which power gives you 1? 0. So this is equal to 0. Therefore, what you get is the log to base b of x divided by 0. We have a denominator 0 now, so this is not defined. Therefore, this is not defined, and we have a problem as soon as we start and take a equal to 0. So the base a of the logarithm shouldn't be 1 either. And also, if we would try to graph this function, let's see what happens. If we have f of x is equal to the log to base 1 of x, then this again has to equal some value y, which takes you, so 1 to the power y will give you x. Let's write that down. 1 to the power y will give you x. But 1 to any power will always lead you to 1. Therefore, x for any y will give you 1. If you try to graph that, you will get the following. So this would be the x-axis, this would be f of x. And you would get a straight line which goes through the value 1. This would be the origin. And this would be the log to this base 1 of x. But you can see that this is not a function. A function has to be single valued, which means that all values on the x-axis get mapped to only one value on the y-axis. But in this case, 1 gets mapped to infinitely many values on the y-axis. Therefore, this is not a function, and this really is not defined. Alright, thanks for watching, rate the video, subscribe, and see you soon again on Lucky Math.